Hello and welcome back to my channel. Students, as you all know, in this problem series we are talking about one of very important topics in organic chemistry, that is general organic chemistry. We have already covered some of beautiful problems including the topics like aromaticity, anti-aromaticity, resonance, carbocations, carbene ions, acidity and basicity. So now let us try to see what is there for us in question number 23. Now, as you all can see, the compound is shown on your slide. You have two nitrogens under scanner in terms of which is more basic and which is less basic. So as you can see, the nitrogen number A and nitrogen number B. Now we will try to see the availability of lone pair, and if it is more available, then we will say that it is more basic in nature, and we will add some fundamentals involving all these concepts. Now let us try the A, nitrogen number A, and we'll see the availability of electrons. Once you see the nitrogen number A, you find that okay, there is a lone pair, and this lone pair is not isolated because it is in conjugation. How? Lone pair, single, double, and because of the presence of delocalization, presence of conjugation, it will get delocalized. The lone pair will shift in forward direction to make a new pi bond. As it goes away, it creates a plus charge, and simultaneously these pi electrons will be shifting towards this carbon, bringing a lone pair and minus formal charge to this carbon, and you can see this particular resonating structure. Now once you see this, you can believe that the lone pair was not localized and it got delocalized over two atoms. Which are those two atoms? On this atom and this atom. So the lone pair is spread, okay, and the extent of its spread, as you can see, on two atoms. Now coming on to nitrogen number B. Once you try how nitrogen number B neighborhood is behaving, you find that again there is a possibility of conjugation. How? Lone pair, single, double. Now you understand. Lone pair, single, double, either you count it clockwise or anti-clockwise. Lone pair, single, double. Now once I say either you count clockwise or anti-clockwise, there comes a very important feature to this cycle, and the feature is it's a cyclic portion of the compound. Second of all, there is a cyclic conjugation involving all the three atoms. How? Lone pair, single, double. So all the three atoms are involved, and it's a flat particle, cyclic conjugation, cyclic portion. If you count total number of electrons involved, then you will find the 2 electrons coming from here and 2 electrons coming from here, and if you count these 2 and 2, you will get 4 pi electrons. Students, once you get these 4 pi electrons, some alarm comes in your mind. It's an alarming situation. Why it's an alarming situation? Because you know that if there is a situation like this, a cyclic portion there, flat portion there, cyclic conjugation there, and there are 4 n pi electrons in the cyclic conjugation, where n can be 1, 2, 3, etc. And if you put n is equal to 1, you get the answer 4 pi electrons. Then such type of behavior is called as anti-aromatic behavior. So you can believe that this case is basically giving you an anti-aromatic behavior. So what I mean to say is, if the lone pair remains here, again listen, if the lone pair remains there, it will be a problem that it will get delocalized and will bring anti-aromatic character, and this will bring instability and it will become unstable. Now you understand, if there is a proton, this proton, if anyways, takes up this electron, and as it takes up electron, now there is no lone pair. The lone pair is now absent, and there will now be no cyclic conjugation. Earlier there was presence of lone pair, and because of that there was a cyclic conjugation and you got 4n pi electrons. But here, as the proton takes up the electron, the cyclic conjugation is lost, and as it is lost, the anti-aromatic character is lost. Is it a good thing or bad thing? It's a very good thing. It's a very good thing. Why? Because now it will be stabilized on losing that anti-aromatic character. On the other hand, A was also, there was a conjugation, and as it was doing the conjugation, mind you, it was not giving the anti-aromatic character. It was this particular ring was already present, and the lone pair was getting delocalized. Okay, so there you can afford delocalization, because in the case of A, the delocalization can be afforded because the anti-aromatic character is not coming. However, in the case of B, if the lone pair is delocalized, the anti-aromatic character will come. So it is better to give it to H plus, so that cyclic conjugation could not be completed and anti-aromatic character is not created. So on that ground, you can see that the nitrogen number B is more eager to give the proton to give the electrons to a proton. So that is very important feature associated with B, and therefore the eagerness of lone pair to be donated to H plus is more in the case of B, because then it will convert from anti-aromatic to non-aromatic. Non-aromatic is a better option, is stabler in comparison to anti-aromatic. So after taking all these things into account, we come to a conclusion that in the case of A and B, B is a stronger electron provider in comparison to A. So that is how you have to think in terms of what are the benefits. Okay, so in both A and B the delocalization was present, but in the B the delocalization was reluctant. It was not happening for something good. So it's better to give it away with eagerness, so that if it is given away, the anti-aromaticity is lost. And that is why we are saying B is more eager, more basic in comparison to A. I hope this was a tricky question. You had to think it critically in that sense, and I hope you must have understood the basics behind how I have explained to solve this question.